Hi, welcome back to educator.com and our series on Java. Today we're going to learn about inheritance. All right, first of all, let's review the two main concepts of composition and inheritance and how they are similar and how they are different. First of all, composition. Composition is sometimes referred to as a has-a relationship. And this allows classes to reference objects of other classes. And so you can build a class out of building block classes. And so an example would be if you have a vehicle, that vehicle is made of component parts. You know, if you buy a vehicle, and if you buy a car, that car wasn't made as a single unit. It is a larger thing that is made up of smaller parts, and at the factory they take all those small parts and put them all together on the assembly line to make the overall vehicle. Same thing is happening here with composition. A class in Java that is composed of other classes can be composed of many different things, many different smaller objects, or just a couple. So a vehicle has a steering wheel, and it has a dashboard, it has wheels, and so forth. Inheritance, on the other hand, is often referred to as an is-a relationship. And so, as we are going to see in some diagrams today, the superclass is where all of the inherited objects below it get all of their attributes and values. And so, inheritance allows a subclass to take on existing attributes of its superclass. And for example, if we stick with our vehicle metaphor here, a sedan is a type of vehicle, a truck is a type of vehicle, a minivan is a type of vehicle. So all of those subclasses are inheriting things like, you know, it has four wheels, runs on gasoline, and all those properties that are coming from the superclass. All right, now to give you a visual diagram here, let me draw something so that you can get another interpretation of what we're talking about here with composition and inheritance. Let's say that we've got our vehicle, and first we are going to talk about composition. Now, that vehicle needs wheels. It probably needs a gas tank. It probably needs some sort of steering mechanism, and it has a number of doors. All right, so here is the composed class, and that composed class is made up of all of these smaller independent objects as well. And so when we run and call our vehicle, if this was a Java program, the vehicle class would then call and use all of the smaller parts. Now let's contrast that with inheritance. And with inheritance, we might say that we start with a superclass of vehicle, and then we might say that a four-door sedan is a type of a vehicle, and a Taurus is a type of a sedan, and a subclass of a Taurus might be, you know, the standard edition series. So here with inheritance, we start with the superclass, and then we're going to learn about the command, the keyword extends. So we would say that the sedan class extends the vehicle class. The Taurus class extends the sedan class, and the standard edition series extends the Taurus class. So you can see the relationship between a composition, a class that's composed of smaller parts, and a series of inherited or extended classes with the concept of inheritance here. All right, now let's talk about the class structure. Sometimes inherited classes specifically are referred to, the superclass is often referred to as the parent class or sometimes the base class. And then if a class is extended from that superclass, that class can be referred to as the child class, the subclass, or sometimes they call that the derived class. Now, the big advantage to inheritance in general is that inheritance allows programmers to reuse these classes without having to redefine them. So it means less code and less development time, and then slightly faster running program. And so it's all about reusing so that you don't have to keep hard coding and retyping all of your classes. Inheritance is somewhat flexible too. So if you have a subclass that inherits values and properties from the superclass and all of these attributes, the subclass can then have different attributes added to it later. So it doesn't have to be an exact carbon copy. The idea is that you're going to have that superclass that has all the base properties, and then you're going to extend it into a subclass and add things to it, modify things to it, because otherwise you just use the base class and leave it as that. So you want to extend the class and give it some variation. Now, so that extended class, the subclass, will still maintain all or some of the attributes of the original class. Now, that's a important concept there, some. Now, what if we want most of the things of the superclass, but we want to change or leave some of the other things out? Then what we need to do is invoke a concept called inheritance overriding. Now let's contrast this with something that we've learned before, which is called overloading. What's the difference between method overriding and method overloading? First of all, let's talk about overriding. Overriding is specifically dealing with inheritance. And overriding will allow the changing of the behavior of that method from the superclass in the subclass. So let's look at a couple examples here. In the superclass, let's say that we have a method, we have a variable called total, and that total is calculated by multiplying two other variables, x and y, right here. Now, if we inherit and extend that superclass into a subclass, then we might want to say in that subclass that we still want we want the method to still be called total, but here in the subclass we want total to be derived by a x divided by y. So we have overridden that method in the subclass. Now with overloading is a little bit simpler of a concept. When you overload a method, it's the same name of the method but just different arguments. And sometimes you call these instance variables. So in instance 1, we might say the total is x times y. In instance 2, we might have other variables, and we say that is a times b. So it's still very similar. We're just changing the numbers around. So we still call it total. It's still using the multiplication operator, and we're just changing the numbers in that calculation. All right, now let's talk about inheritance and how the classes get structured in a hierarchy. And so one of the things that you could talk about inheritance is geometric shapes. So let's say that we start out with any shape, and this could be a shape with curves or a shape with straight sides. If we say then that we want to move into strict polygons, meaning that all of those shapes are going to have straight sides, then we can further define it and say we want a four-sided object, a shape that has four straight sides. We might call that a quadrilangle or a quadrilateral. And then to get more specific, we'd say now let's move into a trapezoid that has at least two parallel sides, right? All right, so we started out with any shape. These could be geometric or curved or straight lines. And then we're going to say we're going to move on to a polygon and any four-sided object, a trapezoid, and then we move on to even more specific, a parallelogram that has two sets of parallel lines. Even more specific, a rectangle, four right angles, and then a square, four right angles and four equal sides. Now, in the concept of inheritance, we would say that a square is a rectangle and a square extends all of the properties of that original rectangle plus, we add that all four sides are equal. And the same is true as we go up the hierarchy. The rectangle extended the parallelogram class, which extended the trapezoid class, and so on until we all get back, so we get all the way back to the shape class is where we started. So the shape class in this structure here is the original base class, and all of the other ones are derived classes from that original class. And as we go, all of these subclasses extend from their original parent class. All right, with the concept of inheritance, the base classes, the main classes, the superclasses have a relationship with the subclasses that is sometimes referred to as protected. So you could say that the subclasses are protected members of their superclass. And what this means is that within a subclass, you can access the superclass's public and protected methods, but not the superclass's private methods. So this is sort of, when it comes to the protected class, this is sort of a cross, a little, go-between, an in-between between the public and the private. So if you have a public method in the superclass, that's accessible by, all other classes, the subclasses that are extended from that superclass and everything else. If it's private, that method can be accessed only by that class itself, only by that superclass. If it's protected, however, the class or the method can be accessed by a subclass if that subclass is extended from the superclass. If it is an outside class, it can't access those protected methods. So you can see how that relationship is sort of like a family. You can think of the superclass as the parents of the family and the subclasses as the children of the family. And if you have protected methods in there, the children can access it, but anybody outside of the family, any classes outside of the family, cannot access it. All right, now let's see some of these concepts in action with some code. And like a lot of things with computers and computer programming, the concept of inheritance is somewhat difficult and somewhat advanced to comprehend. In actual practice, it's relatively easy. You're going to see that once you get a hang of and are able to recognize the extends keyword, you're going to know that inheritance is going on there. And that's pretty much all that needs to be done. It doesn't take a lot of code to use inheritance and to take advantage of it. Knowing what it's doing and knowing why we're putting it in there, that's what takes all the time and the understanding. So this first example here is just a basic program that has inheritance, and it's using constructors. So the first thing we call and initialize here is a simple class that we call A. And then we're going to have this class just output a simple line that says that the A class has been constructed and then has been run when we run it in the prompt. Same thing is true here with the next one, class B. Now notice the keyword extends. We say class B extends A. So all of the attributes that we set up here with A, that A was an integer and so forth, is now taken on by class B. And then we just have an output statement that says B constructor. Same thing happening here. Class C extends B. And then we have an output statement that says class C constructor. And then when we get down to the lower part of the code here, we see that the public class, in general, we're calling this whole overall class basic inheritance. And the public static void statement is listed at the end here, so that when we call C, it is going to go to C, go to B, go to A, and then it's going to print A, B, C all in one motion. All right, let's see what happens here. And also, when it comes to compiling this code, now for inheritance and for constructors, I haven't compiled this code yet, and I want to show you the reason why. If I open up our original folder with the files that we're going to use today, notice how all I've got here is the basic inheritance.java file. It has not been compiled yet. All right, let me cancel out of there and go to our prompt. All right, now when I compile this code, we say javac basic inheritance.java, and the code gets compiled. Now before we run this, Let's go back to our text editor here. Now look at what has happened. We started with just the basic inheritance.java file. When I compiled the code, the basic inheritance.class file came up, and notice all of these component parts. All of these inherited classes that extended from each other. We got class A, class B, and class C down here. So you can see that when this particular program was compiled, it just didn't compile the superclass, it compiled all of the classes so that they are going to run in conjunction with each other. And one class is going to call the other class and so forth. All right, now let's go back to our prompt here and let's see what happens when this program runs. We say Java basic inheritance, and it runs, and it just runs and displays the constructors. So you can see the output of this program doesn't look that impressive, but behind the scenes you can see all of these classes and when it's compiled and all of these files now working with each other as the classes get inherited and extended. All right, let's go to our second example. And in this program, you're going to see a good example of the program exhibiting both composition and inheritance. So similar to our last one, we start with a simple class A that gets initialized first. Then we go and extend that class A to a subclass, sub A. And so that is our sub A constructor now. Same thing's happening here with class B. Here class B is being initialized on its own. So in the previous example, we extended class B from class A. Here class B is on its own. And so we label that constructor with the output statement. Now the sub B1 extends B. It is derived from B. Sub B2 is derived from B. And then sub B3 is extended from B. Then we come down here and we have our third class, third independent class, class C. And then we have class C, class sub C getting extended from that C. And then we've got these private subclasses and the output statement being called down here in subclass C. So this subclass, you can see, is composed of all of these other subclasses. So we've got some of these classes being extended and inheriting attributes from their superclass, and then the larger subclass down here that's going to run them all, in other words. And the public class here is the main class we call composition and inheritance. And then we have the public static void main statement down at the bottom that runs the whole thing. All right, let's see what happens when we run this program. When I try to compile the composition and inheritance, that gets compiled. Now let's go back and take a look at the folder so you can see what happened here. And notice how when I compiled composition and inheritance, the main class file gets created. And in this one, we also had classes and subclasses that were called just A, B, and C. Notice how we still only have one class file for A, B, and C. So what happened here was that, and this is an important warning and a good troubleshooting tip, is that if you have two programs that create subclasses that either are using composition or inheritance that generate subclass files, the second one that you run second is going to overwrite those original ones. So that means that the original program then is not going to be able to be run, and you're going to have runtime errors unless you name those subclasses different things. I'll show you this in a runtime example once we get back out to our prompt. Also, all of those subclasses down here, notice, sub A, sub B1, sub B2, sub B3, and sub C, those also got created at compile time. All right, let's cancel out of here. Let's go back to our prompt. And first, let's run this program, and then let's try to go back and run our basic inheritance and see what happens. All right, so if I say Java composition and inheritance. It runs all of the constructors, and notice how it did not necessarily run them in order. It ran them in the order of that subclass down at the bottom of the program. So we've got C, B, B1, B, B2, B, B3, A, and then sub A and sub C at the bottom. Now, what happens if I say I want to run my basic inheritance program again? Now, here's where we get the error. It says exception in thread main, no such method error. So that means that it tried to call that method C and method A that were overridden by the composition and inheritance program that we compiled. So this is what I mean when I say you're going to get errors unless you have all of your subclasses as they get generated and as they get extended, and at compile time they are going to create those subfiles. All of those subfiles need to be named something different if you're going to have all these programs running at the same time and calling each other. All right, let's look at a couple more examples here. And in this one, we are going to go back to our geometric shapes definitions and metaphors, and we are going to set up a Java program that starts with a superclass of a shape, and actually it's going to start with a superclass of just points. And the program is going to generate virtual shapes with coordinates, XY coordinates, and then we're going to use these superclass shapes to extend down to subclass shapes, such as squares and rectangles and so forth. But first we've got to start with our point. So we start with a public class that we just call point, and we're going to label these XY coordinates with double integers x and y. Then we're going to construct the XY coordinates to set those up so that they can be called by other programs. And then we're going to return those XY coordinates as a string so that they can be called by later programs. All right, let's go to our next one. Here we start with a basic shape of a quadrilateral. All right, and in the quadrilateral we have private methods of points. Notice how these private methods call our original point program, and we've got 4 endpoints for the 4 corners of a quadrilateral. Then in this public constructor, we set up these 4 points to outline at runtime the 4 points of the shape. We have return statements that return those point locations. And then it's going to convert that to a string so that we can then return the coordinates of that quadrilateral to the user in an output statement. Now here's where inheritance comes into play next. Next we have a trapezoid class. This trapezoid class, notice how we say extends the quadrilateral. So the quadrilateral, any shape with 4 straight sides. The trapezoid, however, we're going to set up as similar to the quadrilateral, 4 straight sides, but we've got at least 2 parallel lines in there. So as we define the trapezoid, we already know that it's going to inherit all of those quadrilateral properties, and we can just now tweak it with some additional definition. And so we say that we've got our points, and we further define things that the quadrilateral needs, or that the trapezoid needs, and then we return those coordinates to the user. All right, let's go to our next extension, and this is a parallelogram. So here, similar to what we did last time when the trapezoid extended the quadrilateral, here the parallelogram extends the trapezoid. Takes on all the attributes, and then we add some things to it so that we get 2 sets of parallel lines, and then we return those coordinates out to the user, including the width and the height and the area. So we're going to see the width, height, and area of all these shapes. Next we have the rectangle, and that rectangle extends the parallelogram. Similar, we're going to have the width, area, and height. And then finally our class square definition. The class square extends. Now notice how this could be handled a couple different ways. The class square could be extended from the rectangle, or the class square could be extended from the parallelogram. So a square is a rectangle, but it also is a parallelogram. So you've sort of got, if you visualize this, the parallelogram is the superclass on top, and it extends down to the square and the rectangle, which are children both of the parallelogram. So here, in the way we've got it set up, the square and the rectangles are siblings, as opposed to the other way that you could do it is have the parallelogram sort of as like the grandparent class, the rectangle as the parent class, then the square as the child class in a straight line. So it can be done either way. Here, the square is being extended from the parallelogram. Now, our last program, that is the application, to run it all, we call quadrilateral test. And here is the program that contains the main public static void statement. And these are where we're going to insert all of the points into all these shapes. And then we're going to output those to the user. All right, so let's see what happens when we run this program and we get all of our items. All right, so this program I've already compiled, so I'm just going to run it, and we're going to say Java, and the only one we're going to run is the final application, quadrilateral test. And when I run this, it is going to call all of those previous classes that have been extended from each other. All right, notice what we get. First, it calls the quadrilateral, gives us the coordinates. Coordinates of the trapezoid, gives us the coordinates and gives us the quadrilateral's height and area. Then it calls the parallelogram class, width, height, and area. Then it calls the rectangle class, same system. And then finally it calls the square class, which is the one that we created last, and gives us the coordinates. So here you can see a complex system of the base class, quadrilateral, getting extended down through a lot of subclasses, and then all of them getting called and run at runtime when we run the overall application quadrilateral test. All right, so in this lesson, we've learned about inheritance. We've compared and contrasted inheritance with composition. We've learned the difference between an is-a and a has-a relationship. We've learned how important the extends keyword is if you want to use inheritance. And if you ever see the extends keyword in a Java file, then you know that inheritance is being invoked. And we've seen that at runtime, if you are using inheritance and composition, those subclasses generate their own Java class files, and so you have to be careful to make sure that all of those subclass files are named something different if you want all of those programs to be running simultaneously. All right, next we're going to talk about polymorphism, so we'll see you then, and thank you for watching educator.com.